Hello students, welcome to my channel Foundation Mathematics. In this video, I'll help you out with a sum from the topic Maxima and Minima from applications of derivatives. So let's get started. Let us first comprehend the problem that is given to us. It says that you have to show that the altitude of a right circular cone of maximum volume that can be inscribed in a sphere of radius r units is 4r by 3 units. Right? So what is given to us? We are just given that there is a sphere whose radius is r units. This is the only thing that is given to us. And what do we have to prove? We have to prove that the altitude means height, altitude of a right circular cone whose volume will be maximum is given by 4r by 3 units, keeping in mind that capital R is the radius of the sphere in which the cone is inscribed. So you have to show that the volume of this cone is maximum only when its altitude, which is denoted by h, is given by this value, that is 4r by 3. So for that we refer to this figure and we assume that the radius of the base of the cone be small r units. So let the radius of base of the inscribed cone be small r units. It is not given to us, so we can assume anything. And also let its height or altitude be h units, capital H. Now if you look at the figure, I have taken AB to be the height of the cone and this O is basically the center of the sphere. So let us refer to the figure and we assume that OB is equal to x units. Keep in mind, I will relate this unknown which is h and this unknown which is given by r in terms of x only. So if I can find the value of x which maximizes the volume of the cone, I can definitely find out the value of h and the value of small r. So if you look at this figure, you can very well understand that OA is also equal to capital R, because OA is same as OC, which is the radius of the sphere, right? So we can write h, which is the height of the cone, as OA plus OB. Now what is the value of OA? OA being the radius of the sphere, it is equal to capital R, and we have assumed OB to be small x. Just because we want to keep it in terms of one variable only, we have taken this x. So we can write h as r plus x units. Similarly, if we apply Pythagoras theorem in this triangle OBC, so you have a look at this triangle OBC. So in triangle OBC, we can say that square of OC square should be equal to OB square plus BC square. This is very well known to us. This is from the Pythagoras theorem that we are writing. So what is OC? OC is capital R. We can write r square equal to x square plus small r square. So you see, I am writing this small r square again in terms of x, and of course this r is given to us because this is the radius of the sphere and it is fixed, it is not changing. So we can write small r square as capital R square. Using this, from here we get capital R square minus x square. Now what is the volume of the cone? Volume of a cone is given by 1 by 3 pi r square, which is the radius of the base, into h. So now volume of the cone, which can be denoted by V, is equal to 1/3 pi r square. This is going to be small r square because that is the radius of the base, h, cubic units. Now you see, in this we can replace r square using this value that we have got, and also h can be replaced by this. So ultimately V becomes an expression where the only independent variable is x. So we can write V as 1/3 pi capital R square minus x square, and in place of h we can write r plus x. Clear? So then we can just simplify this. We can multiply the two expressions to get a simplified form for V. So we are getting r cube minus x square r plus x r square minus x cube. So let me denote this by 1. Now you see, V becomes an expression only in terms of one independent variable, which is x, right? So let us first find out dv dx, which is the first order derivative of V with respect to x. So now find out dv dx. What is dv dx? 1/3 pi, d dx of r cube is 0. This gives us minus 2xr. This gives us plus r square, and finally derivative of x cube is 3x square. So we are getting minus 3x square. Let this be denoted by 2. Now what we will do is, we will find out the second order derivative of V with respect to x. That is, we evaluate d2v dx2. That is, we will differentiate 2, that means this expression, with respect to x. So what are we getting? We are getting 1/3 pi. This gives us minus 2r, and from here we are getting minus 6x. So we can take minus 2 common from here. So we are getting minus 2/3 pi r plus 3x. So whatever be the value of x, x is going to be positive, right? So we are getting d2v dx2 as a negative quantity. So let us first find out the value of x from 2, which is going to maximize the value of V, which is the volume of the cone. So for critical points, what do we do? For critical points, we equate the first order derivative with 0, right? So for critical points, we have dv dx equal to 0. So this means we have r square minus 2xr minus 3x square equal to 0. This is a quadratic equation and we can factorize this. You see, the product of the first and the third term is minus 3x square r square. So we can write the middle term, we can write this term as minus 3xr plus xr, right? So this becomes r square minus 3xr plus xr minus 3x square. So what can we take common from the first two? From the first two, we can take r common. So we have r into r minus 3x, and from the last two, we can take x common. So we have plus x into r minus 3x, which is equal to 0. So the two factors are r plus x and r minus 3x equal to 0. Now from here we have r plus x equal to 0, which gives us r equal to minus x, and this is definitely not possible because r is the radius of the sphere. So r cannot be negative, or if we write, even if we write x equal to minus r, then also this is not possible. So let us come to the second quantity. If I can say like this, if a into b is equal to 0 and a is not equal to 0, then obviously b is equal to 0, right? So we will equate this with 0 now. That means r minus 3x is equal to 0. So from here we are getting r equals to 3x, or from here we can write x equals to 1 by 3r. So this is the value of x. Now you have to find out the value of the second order derivative when x is equal to 1 by 3r, and whatever I told you here, only whatever be the value of x, this is coming out to be negative. Still we will find d2v dx2 when x is equal to 1 by 3r. So just substitute for x in this and you will get a negative quantity. So if you put 3x equal to r, this is what you are getting, right? So this is 2r. From here you have 2r. So you are getting minus 4r pi by 3, which is clearly negative, which is less than 0. So definitely volume will be maximum when r is equal to 3x, or x is equal to 1/3 of r, right? So volume is maximum, volume V is maximum when x is given by this 1/3 r. Now if you remember the expression for the altitude, that is h, if you remember the expression, you can easily put the value of x and find the value of h. This is it. So h is capital R plus x, right? So h is capital R plus x. Substitute for x here and you are getting r plus r by 3, which gives you 4r by 3, and hence we have proved that the altitude of the cone, which will make the volume maximum, is given by 4r by 3 units, where r is the radius of the sphere. Hence we have proved this. Thank you for watching.